For a sequence a sub n, with our first term is 2, the number of terms is greater than or equal to 1, our a sub n plus 1 equals s sub n times s sub n plus 1, we're going to find the value of the sum from k equals 4 to n of a sub k. This is going to end up being a telescope series, not a quadratic model, but let's look and see what we have. We're going to have to find the sum for a sub k. So I'm going to look at the sequence a sub n, and note that a sub 1 plus a sub 2 plus dot 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 plus a sub n minus 1 plus a sub n. Look at that. So basically I'm trying to find what this is. And I can do that by taking the sum of all the terms, so the first n terms, and then subtracting the sum of all the terms except the last term. So it would look like that, and that would give me a sub n. And the reason I'm doing that is because we have this a sub n plus 1 here, and we're also looking for a sub k. And I also need to know what kind of sequence we have. Is it arithmetic, is it geometric, or whatever? So let's look at a sub n plus 1. That's given as s sub n times s sub n plus 1. We have a sub n. So if I write this one with a sub n plus 1, everywhere there's an n here, I'm going to put n plus 1. And that's going to give me s sub n plus 1 minus s sub n. And I'm doing that so I have two equations, or two, a sub n plus 1s. And so I can set these equal to each other. So I'm going to set this equal to this sum. So the sum s sub n times s sub n plus 1 equals, and this one's going to be s sub n plus 1 minus s sub n. And to simplify this, to see what kind of sequence we have, I'm going to divide each term by s sub n times s sub n plus 1. So I'll do that. All right. Now, what's going to happen here, this is just going to give me 1. See, that's making it look easier. These two cancel, so I get 1 divided by s sub n. And then I have minus, these two cancel, 1 divided by s sub n plus 1. All right. Now, from that, it's still kind of hard to tell what kind of sequence it is. So let's go ahead and multiply through by negative 1. So that's going to give me, if I rewrite it and multiply, I get 1 divided by s sub n plus 1. This is going to be minus now 1 divided by s sub n equals negative 1. So this is going to be a arithmetic sequence, and we have a sequence that's like 1 divided by s sub n, right? And if you take the sequences and subtract, you're going to get negative 1. If you take the current term and subtract the previous term, like for the summation, you get negative 1. Therefore, our common difference is negative 1. All right, and I think I forgot to put the formula up, but I'll put it up. So since we have a formula a sub n equals your first term plus n minus 1 times d, our first term is given as 2, and our common difference is negative 1. So this is going to give me 1 divided by s sub n equals, my first term is going to be, since this is 2, you have to flip it, so it's going to be 1/2, because we're doing 1 divided by a, because it's divided. And then plus, you do your n minus 1, and your common difference is negative 1. This is going to give you negative 2n plus 3 divided by 2. All right. Therefore, this equals 1 divided by s sub n. Therefore, s sub n is going to equal 2 divided by negative 2n plus 3. All right. So now we have what we had before. We have a sub n equals s sub n minus s sub n minus 1, right? So let's substitute all that in. So this is going to be 2 divided by negative 2n plus 3, and then we're going to subtract this one. So everywhere there's an n, you're going to put n minus 1. So you have negative 2 times n minus 1 plus 3. All right, this simplifies to 2 divided by negative 2n plus 3 minus 2 divided by negative 2n plus 5. All right. Now, if we want, we can rewrite this a little better, too. We can write, and I'm going to do it on the next slide. I'm going to rewrite this because we've got like these 3 negatives here. So let's do that. And this is going to simplify to negative 2 divided by 2n minus 3 plus 2 divided by 2n minus 5. Get rid of some of all those negatives. All right, now what we're going to do next is get our common denominator. So our common denominator is 2n minus 3 times 2n minus 5. Then you have to do this cross here because this one needs this 2n minus 5. So it's going to be negative 2 times 2n minus 5 plus 2 times 2n minus 3. All right, this is going to simplify to, all right, let me just do it on top here. Negative 4n plus 10 plus 4n minus 6. So what happens? The 4n's cancel, right? So we're going to get 4 divided by 2n minus 3 times 2n, is this plus 5? Where am I getting? Oh, it's minus 5. Minus 5. All right. Now, what I can do is note that this is for n is greater than or equal to 2. So now let's go to our a sub k here. This is a long problem, right? So we have the sum from k equals 4 to n of a sub k. So that's going to equal the sum from k equals 4 to n of this 4 divided by 2k minus 3 times 2k minus 5. All right, the problem with this one is we need to do partial fraction decomposition for this one. So that's what I'm going to do. I'm going to deal with this real quick and do some partial fraction decomposition. So just looking at that, I'm going to write 4 divided by 2k minus 3 times 2k minus 5. And I'm going to write this as a divided by 2k minus 3 plus b times 2k minus 5. All right, clearing the fractions, we're going to get 4 equals a times 2k minus 5 plus b times 2k minus 3. All right, so let's let k equal 5 halves, right? So k equals 5 halves. That's going to zero this one out. So you're going to get 4 equals b, and then we have 2 times 5 halves minus 3. So basically we get 4 equals 2b. So b equals 2. All right, so b is 2. And now let's do this one. Let's let k equal 3 halves. that's going to zero that out. So you're going to get 4 equals a times 2 times 3 halves minus 5. So we're going to get 4 equals, let's see here, 3 minus 5, so that's going to be negative 2a. So a is negative 2. So what we have here is my a is negative 2 and my b is 2. So I can break this up like that and pull it out front. So now we're almost done. So now let's see what we get. We're going to have, I'm going to pull everything out. So we're going to have 4. And then we're going to have negative 1/2 times the sum from k equals 4 to n. And I'm just going to have this 1 up here, 2k minus 3 minus 1 divided by 2k minus 5. Let's do that. And anything else? I can rewrite this and get rid of the negative. So we can write this as 4 times 1/2. Then we're going to have the sum of k equals 4 to n. And reverse this. 1 divided by 2k minus 5 minus 1 divided by 2k minus 3. And I'm just going to simplify this to a 2. Just so I don't have to keep writing it. All right. Now what I'm going to do is write some of these out. And well, let me see if I can squeeze it in here. If I write this out, we're going to get 2 times, and we start at 4. So that's going to give me 1/3 minus 1/5. Then we're going to have plus 1/5 minus 1/7. And then we'll have plus 1/7 minus 1/9. Plus dot 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 plus 1 divided by 2 n minus 5 minus 1 divided by 2n minus 3. All right, so let's see. This is a telescope series that's going to collapse. So basically what we're crossing out is the last term here with the first term. Last term with the first term. So last term with the first term. So last term here with this first term. That kind of gives you an idea. We're left with this 1/3 and with this. So basically we have 2 times 1/3 minus 1 divided by 2n minus 3. And this is going to simplify to, this is 2/3. Let's see. We get the common denominator and all that. You're going to get 4n minus 12 divided by 6n minus 9. All right. Or you could pull out the 2/3 and do it that way. But anyway, that's your final answer. Thank you. Have a nice day. Bye-bye.